In this video, I want to talk about working with vectors graphically, and so let's learn how to draw a picture of a vector. So a vector, since it has both a magnitude and a direction, we represent as an arrow, and I'll just draw a vector here that maybe is 2 centimeters long at a certain angle, and it has a direction, so we make it an arrow to specify the direction. And when you label a vector, when you're doing handwritten notation, you can label, say, vector A with a little arrow on top like that. Well, if you see a vector written in a textbook, it's usually just written in boldface. But when you're handwriting a vector, I think the best thing to do is to put a little arrow on top like that. And then another thing that you probably remember about vectors is that they have a magnitude, so that's their length, a direction, and it doesn't really matter where the vector is. In other words, if I keep the angle the same, but I make another vector that, if I try and make the same angle here, is also 2 centimeters long but is somewhere else, and as long as its orientation is the same, this is the same vector. It doesn't really matter where it is. In fact, you can imagine picking a vector up and moving it around the paper. You can put it down wherever you want, as long as you keep its length the same and its orientation the same. In other words, you can't twist it around. You can kind of just pick it up and put it back down somewhere else. It's the same vector. And we can also talk about the negative of a vector. So if I wanted to write the vector negative A, I would do the same direction and the same magnitude. So to start off at least, so try and make it the same direction, except instead of putting the arrow at the end I had it on, I'm going to put it at the other end. In other words, I'm going to change its direction. So that kind of makes sense. If it's negative A, just flips direction. So if two vectors are in the same direction, even if they're not the same magnitude, for instance, if I have another vector B that's the same direction as A but is a different length, so here's my vector B, then I can say that A and B are parallel. Again, it just matters that they're in the same direction. It doesn't matter what their magnitudes are. And then the vector A and negative A, which are in opposite directions, and again, it doesn't matter the magnitudes. Here they happen to be the same, but they don't have to be. I could say that A and negative A are antiparallel, meaning that their orientation is exactly opposite. So it doesn't matter what the magnitudes are, it just matters that their orientations be completely opposite one another.